this will work. Okay. All right, I'm gonna turn you guys on just because I'm just setting it up. But you're on, you're live, so take your time. But it's not that big of a deal. It's just a live stream.
So this title is pretty much in line with the discussion we had.
Yeah, exactly. Speaking of continuous learning, wait, what happened?
Incremental step.
There is 16.
There is a 16.
16, right?
No, wrong thing. Sorry guys, I'm trying to set up the.
Okay, maybe you could just.
There
Yeah. It's just like a whole slide. So
Yeah, yeah.
So are you able to reviews? Let's see.
You can move down there.
Right. Sign up. You gotta make it full screen.
Just try.
Okay, so this is
Doesn't work.
Vincenzo.
No, it didn't work for some reason. I don't know why.
I'm gonna try and set up the
All right, so
text properly.
thank you so much for having me again. Maybe live stream, yeah. Also put the votes on the internet. And yeah, probably I'll speak about the research vision and the works that I've been carrying out at the University of Bologna in the next meeting. Essentially, just a few slides to introduce myself a bit better. My name is Vincenzo Lomonaco. I'm a postdoctoral researcher at the Department of Computer Science and Engineering that is in Bologna, which is one of the ancient university in the world. And
How old is it?
yeah, it is. And
No, how
I
old
mean,
is it?
not for computer science.
No, I know. No, but when was it founded?
It's from the Middle Age, I guess.
Before they had it on.
Exactly. Yeah. So I'm also a research affiliate. Recently become a research affiliate for this private research lab. It is AI Labs in Bologna, and we are now working on more engineering work in the context of continual learning, especially continual learning for automatic video captioning. It's very nice because it's kind of a scale-up problem, I would say, to tackle for continual learning from an engineering point of view. It's high scale. It has two different modalities: speech and natural language processing and computer vision, all in. So it's kind of nice. I'm also a teaching assistant for the machine learning and computer architectures courses department. Yes, the DC department. The same department where I'm working on in the Cesena outpost, I would say, of the University of Bologna.
When you say computer architecture, you mean like hardware architecture?
Yeah,
and
it's
stuff? Okay.
really basic stuff for the bachelor degree, so CPUs, their distractions. Then I've been also the author for the massive online course Deep Learning with R for Pact Publishing, and also technical reviewer for the book Deep Learning R Deep Learning Essentials.
Are you a co-author or the sole author? Or you...
No, I'm the sole author for the online course, so I guess 5 hours total recording.
Is the online course available on one of the like Coursera or something?
On the Pact Publishing platform, this online platform. It's a publisher. It's a publisher that has also this platform for online courses. And
So
then
people take this course and then you have to.
people can take this course on several platforms, also Udemy, and I know they sell this course.
Do you moderate them? Are you actually?
No, I just recorded the lessons along with the
Someone
exercise.
takes the class who teaches it or who checks the assignments or.
A student can start the course. It is organized in, I don't know, 12 lessons, something like that. And then you have also all the material, the code, and the notebooks. Actually, are notebooks in.
I'm just saying, if I did an assignment, who's grades it?
No, it's not graded. It's not. It's just online course without grading part.
But it's totally all stuff.
Yeah.
But it's available on Udemy as well?
Yes.
Or?
Yes. Udemy, and then some other platforms. I don't remember.
you have a sense of how long has it been out there?
Several years now,
And
3 years. I don't know.
how many people?
No, I don't know that.
You don't know?
But I've seen a few reviews with the,
You
average reviews.
You
on
get
it.
some feedback about.
I mean, it's. I can do an estimate, I guess, based on the royalties that I get. So, yeah. So, but I mean, the downloads and the subscriptions have been quite a lot, I would say. I wouldn't expect the number of submissions around the world. I mean, they are doing an amazing job at publishing to divulge, let's say, the work, and they have a marketing team that I don't know anything about, but they do an amazing job on that.
Right, so do you get paid for that?
Yeah.
Okay.
Then I'm also now working on the third sector, in the non-profit sector, more recently. So I recently co-founded continualai.org, which is an open community, a non-profit research organization on continual learning for AI. And maybe I'll spend a few words about it in the next slide. And then I'm also the co-founder, board member of Data Science Bologna, a local community in the city of Bologna. And this instead AI for People is another project we are trying to put together a bit of people from different backgrounds, not just computer science, especially from the human side, philosophy, and with the idea of working already on the integration of and design objectives for making from the start algorithms that can already somehow respect our human culture and values, or at least rules.
Is this based on? That's interesting. Is this based on sort of fears about what? There could be a spectrum, like, oh, we just build AI systems that are they're integrated in society well, or it could be like, oh, AI is going to destroy the world.
Well, no, it's more of a political, let's say, approach in which we would like to develop policies, or at least with the experts on the field. For example, we are part of the European Alliance for Artificial Intelligence. What the idea is to try to come up with some guidelines to develop systems that are already, for example, not biased with respect to the particular aspects and so on and so forth. So it's a work in progress, but the idea is more of a political effort in which technical guys start to interact and develop, this attitude of integrating by starting in the design, these algorithms. They already integrate some aspect that we would like to take on the applications of privacy issues, fairness, biases of various
Bias
nature.
is a big one these days.
Yeah. But yeah, that's just an aspect. I mean, I'm interested in.
I'm not sure. I've read of efforts along this line.
Yeah.
But I didn't know if it was this organization, if there's multiple organizations.
There are many now, especially in Europe now. They are working a lot on this aspect. They think that in Europe we can have a real impact on this, maybe more than US. So they are pushing a lot on this on this aspect. No, because in technical part, of course, China and United States are much stronger than at least up to now than the European Union in terms of funding, in terms of advancements, in terms of companies. All right, so then what is continual AI? So the idea started a few years back when I was starting to invest my time in this research, let's say, topic, the idea of having machines that can learn continuously. And as we were discussing before, it was not the case for state-of-the-art neural networks at the time. It was in 2014, I did this the first my master dissertation. That was about convolutional neural networks and HTM's system for object recognition in context of computer vision. And at the time, essentially, convolutional neural networks were the state of the art for computer vision, recognize things and object, for example, in context computer vision and learn and continue. So that was very interesting to me. I started to work on my PhD trying to integrate this property in these systems, the architectures in general. And but there were nothing out there. I mean, it was very difficult to find papers and materials, everything, people that were interested in discussing about these things. And so the idea was to create a little group of people, a community in which we could share somehow these ideas and material and so on and so forth. So we started with a simple GitHub page in which we listed as an open effort. Everyone who can still today push their own stuff, and the idea was to create at least a web page in which there were a lot of links pointing out to different things. But then it grows somehow, and so in the end we decided to create an official non-profit organization from that. Now we have more than 500 members around the world from several institutions, and then very recently we are proposing now we have submitted a workshop proposal for CVPR 2020 to based also on continual AI for continual learning for computer vision. So let's hope that will be accepted so that we can really launch a bit better this platform and this community.
So it's really a collection of members doing various things.
Yeah, exactly. So
there's no center for where this research is. You're not conducting research.
No, because we don't have a lot of funding. It's completely.
Probably call it a research organization.
Yeah, because that's the idea. That would be exactly. No, that would be the idea, that if this organization can grow, but in terms of community engagement, and there is a will to. It is organized as an Italian association, so it's very. It has its rule, it has its statute. Everything is in place. A very democratic approach to developing this thing, and so it could grow. And the idea is we had several objectives. The first one is to connect researchers. The second one will be to actually propose new research and work on some research topics that are interesting for the people in this organization, and then also to help disseminate research in this context, also that people acquire new knowledge in this. And so we are actually a few members now. We are going to elect before, I guess, the end of the year, other 6 board members from the community itself. These were the co-founding members, and then we had also a couple of advisors for various companies, including Vincenzo.
I don't think I've actually ever given any advice. You haven't asked me.
No. I mean,
but if you asked me, would you want to be an advisor? I said sure. I'd be happy to help.
No, because the idea it was to. No, but the idea was to have a group of advisors.
Why is it so funny?
Somehow cover the entire aspect, of continual learning from a more biological perspective, from a more company-oriented, maybe from neural perspective, and from the research university, from other research corporations. So the idea was to have a broad coverage of the entire space.
Mm-hmm.
So we'll see in the first years of the organization. We will try to push a bit more. We'll see what happens.
Great.
So that's all for continual AI. Then I'm now part of this line of research at the BioLab group. So Davide Maldoni is the lead of this, let's say, machine intelligence-oriented group. I am the postdoctoral researcher, and then we have other 2 PhD students, Lorenzo Pellegrini and Gabriele Graffieri, that are now working on continual learning with the architectures.
They are, or they're not?
They are.
Okay, so all 3 of you are, all 4 of you are working.
Gabriele with more of an explicit research interest on generative model for continual learning. Lorenzo instead is more focused on the engineering part, trying to bring continual learning on embedded devices and robotics and stuff like that. So that's
Cool. Okay,
that's
great. Yeah. And then sometime later in the week or next week, we can talk more about your actual research topics and stuff like that. Oh, okay. Oh.
Biolab is the name of the research group that Davide is leading.
But is it really biological?
No, it's Biometrics. It was starting from Biometrics. He's well known in the context of fingerprint recognition. He brought the
biometrics lab.
Yep. It's a biometric lab. Then let's say that Davide started in 2011 when he read your book to work on HTM, and it was his first PhD working on that too. And then we somehow continued on that line that has nothing to do with biometrics.
Okay.
And when you worked on HTM, was it the first generation?
It was the first generation.
Okay.
It was a custom implementation of the first generation.
With the grouping and the temporal.
Splitter. From the Lab George. Easy sort.
Yeah. Cool.
Okay. Right.
I don't know how. Let's see.
It was the outline for the.
We have a little bit more time if you want to talk about your personal trajectory. Yeah, we can go see how far we can.
Okay.
We have a little bit more time.
Great.
Yeah.
So the idea was here to start with. I developed these slides to present here in Meta. So the idea was to find also the connections with these realities, since it was an inspiration for me. And also the motive, I got in touch with Davide Maltoni at the time. So the idea to work on this stuff and work on my master dissertation already with Davide to then proceed with the PhD. So the idea is, I've been, if you start that in 2014, I met Davide Maltoni was working already on HTMs for 2011. And so actually he invited me to read the book on intelligence, and I read it, and it was a very important inspiration for me and for the idea.
Did you read it in Italian or English?
In English. Yeah. So for me, it was very important with the idea of pursuing not only, this research path in terms of long-term vision to understand the key computational principles of intelligence and then build it in machines, but also with the idea of pursuing, let's say, this life idea of working research in the research world. So pursuing my PhD and so on and so forth. So thank you for that, Jeff. And then what we did was to work on what it was already there. So this comparison with HTM's implementation that David already had. It had another PhD student, I guess it was Eric Ren, that then he went to Vicarious. I don't know if you know him, but for a few times. He worked on this stuff, and then in fact, part of the publications that I put it here are with him, David and him essentially try to integrate backpropagation into that kind of model. And so it was working quite well. And so in fact, in my master thesis, we showed that actually HTM's implementation with that kind of backprop were working better than the CNNs on a very low-dimensional problem. The time was NORB with 32 by 32 images, little toy model. It was working probably also, I don't want to say stupid things, but probably better than the benchmarks that were Numenta or at the time, I don't know, providing for vision. So we were working on the CNN's benchmarks, and we were able to learn with a little. If you look at the performances,
he's talking about really old stuff.
The entire bench
old Numenta tech before open source
could reach the same level of accuracy, but with lower number of data points. the curve was much better for the HTM implementation. So that was the result essentially of my master thesis there. And then what happened is that I moved to start my PhD on this idea of essentially putting more biological stuff into deeper networks, deep neural networks. At the time were just CNNs, essentially. And yeah, and then we had to decide to essentially abandon the first generation of the custom implementation of that generation of algorithms. One motive was just that it seemed that you guys were abandoning also the implementation. So it was a bit of working on alone in the entire space on this stuff, and it was very. No, so the idea was we encountered a couple of problems where we were trying to scale up somehow to work on more state-of-the-art benchmarks, for example, on bigger than 32 by 32 grayscale images, and so we got rejected for ICLR when we tried around that time to do something. They were saying, what is the HTM model? It's not working better. It's why do you use it? And you should use it on more state-of-the-art and not toy benchmarks like that. So at the time, that was one of the reasons also why we abandoned it. It was very difficult to scale in terms of numerical problems, in terms of many things that at the same time, let's say that the CNNs were really used by a lot of people in the community. So a little tricks there and little tricks there. Mm-hmm. You could gather in just a few papers that you read a lot of knowledge and improve your especially practical applications that you could solve in a matter of weeks. So at the time we decided that it was not worth it, and instead we decided to focus on a single aspect that we thought it was worth integrating, and then that was continual learning. That with respect to other principles that you highlighted in the book or in some of your talks. That was one aspect that we think was completely ignored at the time by the machine learning community. Instead, sparsity or hierarchical learning, sequence learning, all this stuff were somehow part of the community. It was people talking about that. And so then I spent I did a few visits, one at Purdue University under the supervision of Professor Ginio Colorcello, working on specifically reinforcement learning and unsupervised learning, also continual. So the idea of lowering a bit the amount of supervision. And then I've been also 1 month in Paris in the automatic systems and robotics lab led by David Filiat, to try to understand what could be done to transfer what we have seen in recent years within the deep learning community for continual learning, to transfer it to the robotics community. The holy grail of robotics has always been this idea of developmental robotics. That is very similar to continual learning. So that was the idea. So then in 2018, this year, in April, I defended my PhD dissertation, Continual Learning with Deep Architectures, where I tried to put all together somehow with a framework and a bit more comprehensive, view on continual learning within the, let's say, after the deep learning revolution, after this idea of creating, a hierarchy of representations, hierarchical representations. And so these are the first generation HTMs, and then we also did a nice work there. The last one, I'm part of it, the semi-supervised tuning from temporal coherence, where we still used HTMs, and we showed that you could store from a pre-trained HTM model, and then if you show to this pre-trained model an unlabeled video, then you could use temporal coherence to somehow improve your ability to recognize the same objects that you've already seen before in the pre-training phase. And so this was working better than CNNs at the time. We couldn't make CNNs work on this, and so that was an interesting result the robustness, I would say, on the HTM in that case. Because also, I don't know if this is, do you agree with this? But this is at least the external perception of a guy not working directly on the HTM theory. But this is what at least.
Have you read our recent papers on the neuroscience?
Yeah, it was very nice to read it. But the one on the Thousandth Brain theory.
Yeah, the framework paper.
Yeah. It's I mean, not in details, but it was nice to read. At least in this idea was pretty new on the.
Were you able to follow that paper? Or is it?
Yeah, I mean, a part of it, much of it. This idea, it's very interesting. This, I mean, I've written there distributed parallel modeling.
Yeah.
But I don't know how to call it in terms of principles of intelligence. But the idea that you don't have only this hierarchy, you don't put all the stuff as an input, condensed input, but we have this very distributed stuff working in parallel. So that's really nice and something that is completely ignored, I agree, now in the machine learning community. Then also, I would say pretty much all the idea of sensory motor integration is also ignored. But the idea that, I mean, at least my personal view on this is that all the other properties, I don't know if you agree, are properties of the HTM theories, but at least they are something you consider, right? Important. Yeah. They are being integrating over time in the last 5 years also. They are being more and more integrated into deep models, I would say.
Especially 1 to 4, but I'm not sure if it's 5 or 6.
No, 5 and 6. I just they are down there because they are not integrated. I think now at the moment. Maybe a bit 5 in the context of reinforcement learning. They now use a bit of information on your actions to build a more robust model of the world. Not
the 3D modeling.
No, exactly. That's completely missing. Yeah. But it's also a kind of more recent developments of the HTM here. But yeah, my whole point is that then first of all, I'd like to separate the idea that you have basic principles and then you have emerging properties. And what is nice to focus on is the principles that you want to embed in a system. And of course, I think much of there's a bit of confusion about this in the sense that many researchers, they try to focus on the emerging properties directly. And not on the very core principles from which these emerging.
Well, that's exactly what we're talking about.
Yeah, exactly. Yeah. But my perception on this also to came back on that idea is that I try to put it in graph. I understand that it's subjective. It's completely not an objective graph. But the idea is that we have on one axis, on the x-axis, we have the neuroscience grounding of the proposals that have been over time in AI, and then we have the practical functionality engineering. Let's say the ability of solve real-world problems in their particular time, in the time in which they have been proposed. And so I also put there in green the different families of AI approaches that Pedro Domingos talks about, just to cover a bit more of everything. But essentially the green points are more general approaches. The red points are, let's say, neural networks, gradient based, I would say, evolution, and then I put also there the HTM implementation. I would say that at least on Wikipedia now it says that there are 3 different generations of Wikipedia. So
what's like the 3rd generation? Is that what we're doing now?
With sensory motor integration. I don't know if that's a discriminant.
We don't use the term CLA anymore.
No, we don't use CLA, but in my onboarding thing, I have kind of a similar thing. The first, second, third. It's kind of
I think the Wikipedia is written
very
roughly.
roughly.
The first one is the one that we use. The second one is the population of neurons. Second generation. Then we have the integration sensory motor stuff.
Yeah.
And,
I mean, there's one big difference is that I don't know how much we want to go into, but the first generation was a set of stuff, and then there was a dramatic break in the implementation and the mentality and how we're approaching it, and then it's sort of we keep adding to it. And from that point on, one thing builds on top of the other. Whereas, between the first and second,
Yeah.
there's a big
A
break.
big gap. Yeah, but I just put them there in the sense that
Yeah.
I think that they are more and more neuroscience grounded.
Oh, yeah.
But they are at least from my knowledge, they are kind of they can solve problems kind of the same level as CNNs and
Well,
for one
we
neural
haven't-
network, right?
We haven't really tried to solve problems at all with the third generation.
Yeah.
Okay. But just to put them there.
Yeah,
But
yeah,
the idea
It's good.
the idea that I was trying to say here, the point is that for me, at least the neuroscience, the neural networks community, the deep learning community was already is evolving towards that particular vision that has been always there in the HTM theory, and
Which vision? The vision of
this idea of the idea of intelligence arising from several principles that have been highlighted from these principles, at least some.
But not necessarily the biological.
No.
Right, the neuroscience grounding, you think they're moving in that direction too?
I think, for example, why I put the red representation,
Okay.
and you end up with CNNs or deep CNNs.
Yeah, okay. I see what you're saying.
Deep CNNs. Then you have, for example, the idea that is very interesting for me, that you put together sequence learning and hierarchical representation, that is, let's say, convolutional STMs, for example, for tackling these description, image captioning neural networks, for example.
Yeah.
You have to take into account sequence learning, the idea that things are sequential, and also the idea to reason on a spatial and hierarchical level, otherwise you can compress information. So that was a very interesting point in time in which we, for example, realized in terms of deep learning community that you need to put all these two principles together. And then the same, we are moving towards, for example, less and less directly supervised stuff, for example, in the context of deep reinforcement learning. And then continual learning, we started to work putting, let's say, the emphasis on the idea to learn continuously, but on top of all of that.
Yeah.
So the idea of hierarchical representation, the idea of sequential learning is now very, let's say, easier to integrate in continual learning since we have a stream. And then the idea of learning continual, the idea that, for example, in sparsity. Now we are starting to realize in continual learning that sparsity is an important property, since you can have less, for example, connections, weights that you have to preserve. You have to make more room to.
Is that becoming more understood in the
community? I think that there's a paper now that has been accepted. I don't remember if ACLR or CVPR. It was very nice. Maybe I send you the link.
That could be a good journal club thing for us.
I mean, it's. I think that for people working on the learning, it's pretty clear that you need to occupy, let's say, as little space as possible in the network, since you tend to oversaturate it very quickly if you don't use any sparsity. So with the idea that I think that, and also another thing to notice is that in continual learning, it was an important step, because we actually went a bit back in terms of things that we could solve. So with continual learning, this is very new.
Well, that's kind of like what we did, right?
Exactly. So no,
we're saying, okay, we're going to focus on the biology at least for the next 3 years.
Yeah.
And we're not going to focus on the performance of the network, the functionality of the network. We're really just trying to get the basics.
Yeah.
So our approach is, I think the most important part of this slide to me is there's a point where everyone's trying to get to, which I don't think everyone, and that point includes neuroscience grounding. And I think a lot of neuroscience AI researchers don't accept that. But that's what we would agree.
Yeah.
So there's different approaches to get there. We've decided to go low and over, then up. And other people have gone up.
Exactly.
I'd say maybe another way to say it, like deep learning, many researchers would be totally fine if they were at this.
Exactly.
Yeah.
No, but I think that the field is normally shifting towards what I think will be the necessary next step, the idea of integrating neuroscience based.
I've felt that for the last year, people are a lot more open to the neuroscience.
I think that we're gonna get there, even though there are people that, for example, working in continual learning, they do things that maybe are completely not biology
I think-
inspired.
I
That's
think
cool.
That's what you said. A lot of people
Yeah.
want to go vertically.
Yeah.
Some people are starting to think that maybe you have to go a little bit to the right.
Mm.
We've always felt you have to be all the way to the right, and so it's just different approaches to get there,
Mm.
right? So these are complementary ideas. People can improve all these machine learning
Yeah.
techniques and really develop some skills. We're trying to do all the neuroscience thing, and I guess one way to look at our world is, I've always felt like the way to get, first of all, just the agreement that this is the point you want to be at is like a big deal.
Mm.
As troops, I see a lot of people are happy to be here.
Yeah.
So we're saying, no, you gotta be there. And our approach has been like, I think the quickest way to get there is to go this way, which is a little bit out of the way, but then you go that way quickly.
Yeah.
And other people are sort of saying, no, we'll go this way, and maybe eventually get there. And you've kind of put these guys on this path, a little bit more direct than I would think, but I would think these are more.
Yeah.
Because most of the people working on this don't know that that's where they're headed.
Yeah.
Right? And most of them are pointing in this direction. They're kind of like, maybe.
Mm-hmm.
Anyway, so I think as a field, we want to get with the best achievement we could possibly do is to get everyone to agree that that's the point we want to be at.
Mm.
And if you agree that's the point you want to be at, then our work becomes extremely relevant.
Yeah.
But if you don't, if you think this is the point you want to be at, then our work seems to be out of left field. So anyway, it's a nice chart.
Yeah, that's my personal view, and then I think that continual learning, especially, it's a nice step in the sense that it is the first time maybe the deep learning community is saying, okay, we can focus on something that is not really advancing the ability to, the engineering ability to solve things.
Yeah.
So in continual learning, we are focusing on easier problem, for example, in computer vision than before. It's kind of interesting. Maybe it's
Well, that puts you more in the research realm versus the engineering realm. That's good. Not many people would have this chart.
Yeah.
So this is
Okay.
let me know. Yeah.
Yeah, I don't know. Okay. Yeah, this might be a good point
Yeah,
to break. 'Cause now you're this would be a great place to start the next
exactly.
thing.
Perfect.
Yeah, this is great. Thank you.
Great.
Thank you for
Thank
putting
you.
all this together. And happy to have you here.
Thank you again.
Okay.
All right, you guys, I'm gonna shut off
Can
the
we
stream.
stop streaming?
I'm gonna shut off the stream.
Yet
just a
again.
minute. Okay, you're off. Okay, you guys, thanks for watching. Don't forget to like the video and subscribe to the channel. I don't know what's going on with the chat right there. It's been weird this whole time. Now it's not even coming up. So thank you for watching. See you later. I gotta figure out how do I stop. I think I just have to do this. Stop.